Hello, everyone. Welcome to Data Science and AI in Business meetup. It's our second combined meetup, and we are leveraging Remo platform. I think there will be still some more people joining us, but we'll start the presentation. Bruce?
Thanks very much, Martian. Can you hear me all right?
I can hear you.
Excellent. So welcome, everyone. Thanks very much for coming. Thank you for coming to the second combined Edmonton AI ML business and data science meetup. And I want to thank Martian for working with our business group so we can create a much larger meetup for everyone here in Edmonton. So this is the second combined one. Our objective moving forward is to hold this event on the first Wednesday of every month. And we want to do two things. We've originally had myself and Corey Jansen started the YAG AI/ML business meetup. And really what we're trying to do is improve the quality and quantity of AI/ML deal flow, create more investable AI-related deals in the city of Edmonton. And we realize in doing so, you really do need the combination of business talent and product development expertise combined with technical talent. And that's really what the data science meetup group that Martian's been running for quite a while. They created a meetup that was really a place to learn about data science and to network with fellow data scientists. So that's really the intention, is to get these two groups together so we can create a larger AI community industry here in Edmonton. We will plan to do this. We're obviously doing this virtually for obvious reasons, but we will get back when appropriate to a live and in-person event so we can have much better networking capabilities when to do it in person. So we're going to use Remo, the platform we're on now, and thanks again to Startup Edmonton for allowing us to do this. And after the event is done, we'll keep the event live, and you can do some networking into the individual rooms. So today, we're really pleased to have two presentations, one on the business side. And as I said, we're focused. The first presentation will be on the business side of things. The second will be on the data science side. This event has been sponsored from the beginning by AltaML. When we had this live, they were buying the breakfast and giving some staff time to work on these meetups as well. So we don't have Corey Jansen today, but we have actually one person better. We have Nicole Jansen, who is the co-founder and co-CEO of AltaML. And I'd just like to actually turn it over to Nicole to say a few words about what's happening at AltaML and can talk on their behalf. So I'm going to stop sharing the screen, Nicole, and I will let you take it from here for a few minutes.
Thanks, Bruce. And Bruce, you're right. I am the better one to be here. So thanks for letting everybody know. Yes, I'm here from AltaML. Very excited to be here. Thrilled to see these two great meetups coming together as one. There's value on both sides, and I think it's important to have those two lenses coming into this view and getting the opportunity to hear kind of both sides, both from the technical and business side. You know, at AltaML, we've been busy building software products with machine learning at the core, and this has been a crazy year for us. We've more than doubled throughout COVID, which means that there's more than half of our team I've never met in person, which seems incredibly strange to me. But we've all lived those core values of happy, humble, agile, and gritty this year as we've figured out how to navigate this world along with everyone else. We've been really lucky to tackle a bunch of use cases in a lot of different industries, including health, financial services, energy, utilities, insurance, so on and so forth. You know, we're nearing that 200 use cases mark of being able to see all kinds of different examples and uses for machine learning. We've got a few of our products in the alpha stage, and one's looking very close to the beta stage. So we're really excited about that and planning on launching a product or two in 2021. And we're also really looking forward to, in 2021, getting back into our offices. We have 3 brand new offices in Edmonton, Calgary, and Toronto, and they're all feeling very, very neglected and waiting desperately for us to return. So we're looking forward to that. Some of you may know we have the Applied AI Lab in Calgary. That's an internship program that we train individuals in cohorts through our, working with our teams. We're looking to expand that and hopefully seeing some opportunities in Edmonton as well. And then another key focus this year is going to be around responsible AI and ensuring not only the work we do is in that responsible realm, but also that we're leaders in that area for the entire industry. So those are some exciting things coming down the pipe for us in 2021. And I'll turn it back to you, Bruce and Marcin.
Great. Thanks very much, Nicole. Really appreciate the update on what's happening in AltaML. And I think that if people don't know, AltaML's office is in 103rd Street Center downtown, and they have a really cool open area that I'm hoping we can hold this event there in the building and have everyone meet in person. So thanks very much for that. Let me go back to the presentation. And so one of the other things that Nicole said, that they've got a presence in Calgary, and we're actually hoping that we'll be able to bring some Calgary companies into this event as well. So we'll be talking about that at a future date. So tonight, we're really pleased to have 2 presenters. Our first presenter on the business side is Myrna Bittner. Myrna is the CEO and co-founder of Run With It Synthetics. Myrna got her BA and also her MBA from the University of Alberta. And she started her first tech company in 1992, developing a commercial internet groupware product that was used by NASA and US West for real-time remote communications. She then co-founded a research company that was actually funded by an Australian billionaire that was building 3D neural net visualization. So she was in this technology a long, long time ago, long before many other people even heard about this technology, including myself in the AI space. So Run With It Synthetics today is a single synthetic environment company, de-risking and optimizing complex systems and scenarios in energy, sustainability, digital media, health, mobility, climate, cyber, and defense. So Myrna's going to tell us about that. But also the company's developed some relationships with local and international clients like Drivewise, Axtel, Alestra, AT&T. And the company is also named as the finalist for a Manning Innovation Award. And Myrna herself was actually was honored with the 2019 Emergent Innovator Award from the Alberta Women Entrepreneurs Organization. Myrna is also a member of the A100 here in Alberta, a community member for the Community Action on Mental Health and Addiction, and an industry member for the ICTC Smart Cities Technology Task Force. She's really passionate about topics related to inclusion, diversity, and representation, and obviously her business. So her talk today is called Seeing Things Differently. And so Myrna, you have 20 minutes, 25 minutes or roughly. I will stop sharing my screen. I also just want to say to everyone in the crowd, I'll be moderating a chat afterwards, after the questions. So if you have questions, put them in the chat, and then I'll ask them to Myrna at the end of the presentation. So Myrna, I'll turn it over to you.
Thanks so much, Bruce. Wow, that was quite the intro. And as Bruce said, really happy to be here tonight and happy to share some of my experience and things that I'm really passionate about when we're looking at building this deal flow in AI and ML in the province. I think it's really important to address diversity. And so that's a little bit about my presentation is going to be tonight, about how and where that has gotten us. I see lots of familiar faces in the audience list here before I go in to share my screen, and just really wanted to reconnect with you afterwards, if I can. You'll probably recognize some of this story, some of you. Everybody can hear my screen, or you hear me and see my screen, I take it. I can't see you. I can just see a green light. But anyways, so perfect. Thanks, Bruce. I really, have had quite a long history in technology and an early history in artificial intelligence in the 90s, and have been through a winter before, AI winter, and after that winter, lots of adventures in a whole bunch of incredible life experiences landed me here, and I really wanted to make sure that when we're talking about AI and ML in the community, and that we make room for different voices in our community, and that we really give these voices legitimacy and value and equal space and opportunity at the table. And I just want to talk to that from my experience, and that's really the only thing I'm qualified to talk about is my experience. So Run With It is 7 years old, and started here in Edmonton. And one consistent theme through the last 7 years is, and you'll hear it again and again if you're out there pitching, is tell a children's story. And it's been said to me really nicely sometimes, and sometimes not so nicely. But it's a bit challenging in the AI and ML sphere to tell this children's story that the community is demanding, and the community being Silicon Valley. It doesn't matter where you go, what pitch competition you're in. And so I just wanted to say, to all of those voices, I heard you. But as diversity brings difference. Here's my children's story, and I think it's a little bit different than what everybody is expecting. So as a mom, I've told a lot of children's stories, and this is kind of the synopsis of how my story blends in with one of my favorites, which was called Mr. Carey's Garden by Jane Cutler. And in Mr. Carey's garden, Mr. Carey's surrounded by neighbors who are all really good gardeners. And they're always offering him advice because he has snails in his garden. And they eat holes in his plants. And the other neighbors are quite concerned, and they give him lots of advice. And they tell him he should, put salt on them to shrivel them up, and poison them and freeze them, and they're really, kind of encouraging and want to help him get over his problem. And he keeps mysteriously saying, "But I see things in a different light," and that's kind of the beginning and the genesis of my company, Run With It. Some of you might recognize these pictures. In the first few years, we stayed fairly quiet, and we were trying to figure out what we had and what its potential was, and inventing just a ton of different things, watching what happened to them and how they were used, and which ones had value, and did any of the business models out there work for what we were delivering. And really, one of the central focuses was, is this what we wanted to wake up and do every day? And who did we want to do it with? Some of these pictures are from my first demo camp here in Edmonton and launch party. And that was kind of in 2016. So 2 years after we had been in business, generating revenue. We actually came out out of the closet in the local community and onto the stage. And I remember my first demo camp presentation, Mac Mail, who's just a wonderful author and contributor to the community, wrote that it was the nerdiest presentation he'd ever heard. And I think that was a nice way of saying that nobody really understood what we were talking about and what we were presenting. And it was a bit daunting after that because we, there was some bit bucketing. So we got positioned as being a testing product and kind of dismissed as that and held as that. There was a lot of kind of outreach from the community saying we needed to focus. We had to pick a sector. We had to put it in a box. We had to make a SaaS out of it. We needed 10x capital to make $1 growth in revenue. VC was really, so venture capital was the resounding kind of message. And it was really kind of a concern because we didn't have AI as being a forefront in our messaging or our terminology for our company. founded on deep tech and lots of, 25 years of AI IP. But we didn't kind of choose to take that path. And so like Mr. Carey, I think, who, politely replied, I see things in a different light. We were lucky enough to be able to have some great clients to keep us going as we figured this out. And we kept bubbling along and really trying to discover our value. We explored some of the far corners of the world, and we took any opportunity to talk to really diverse sectors and take part in trade acceleration programs, alliance programs, challenges. But as you can see, like you look at these images on the screen, and we're not really clear what we were yet. But we knew we were going to become something, and we needed the time to become something. We had a lot of valued potential in the hands of our clients, and we just had to be patient. I think that there was we have bounced through the community and found homes in some of the programs, and some of the funding programs has been incredibly helpful to our growth. But it took a while because we weren't the same. We weren't pitching for investment. We didn't have an investor deck. We didn't have the same growth rate that people were looking for. We didn't have the same, kind of customer churn and ratios that SaaS companies had, and SaaS was really big back then. So it was a challenge because not only were we inventing technology, but we were inventing business models around it as well, and so we had to kind of continue to go quiet. And this is kind of the next step in Mr. Carey's garden children's story, is that one night his neighbors happened to and looking around the neighborhood when the moon was out. And they noticed that the snails were kind of making these gleaming ribbons, and the moonlight was shining off of them in his garden. And then the moonlight was shining through the leaves and making these beautiful lace patterns. And that was kind of what happened to us too, is there was a real turning point for us. But this was after a lot of patience and a lot of hard work. And but really what happened was, kind of the next step in our evolution. And this next step happened to be a turning point where we were invited to be the IoT World Expo keynote. So from relative obscurity to being on the main stage in Silicon Valley with one of the world's largest industrial technology companies for smart cities. And they had seen a revamp of one of those awkward things that we showed at the launch party here in Edmonton in 2016. And it was of an emergency event wearable technology that we had wrapped in a synthetic environment and created an event and watched the human-machine interface and biometrics even of people, synthetic people in that environment. And they said, well, hey, we would really like it if you could create an earthquake for us, so we could strategically position our technology in front of Silicon Valley and the IoT world, and help them understand how our products can be used for resilience. And so they said, can you create the city? Can you populate it? And then can you make an earthquake happen? And lo and behold, we could. We actually had the scale capability. We had the reactive responsive entities, synthetic intelligence entities, we framed them as, and we could fill a city with reactive responsive agents. We had the street cred for being able to wrap device technology. Devices control sensors, so we could wrap their utility technology and put it in this environment. We had the geospatial modeling capability and movement after working with Drivewise. So we were able to actually create people and traffic and movement in this model that reacted and responded to completely dynamic characteristics around it. And all we really needed then was to be able to add an earthquake, which was fairly easy and relatively easy to access all of the information about particular areas in Silicon Valley. And it's a lot to take in, but I think this is kind of what I guess one of my main messages is that this is what diversity kind of engenders, is being able to take that time to build those things, to maybe not entirely focus, but to explore and to invent and to add, and to really not be pressured into that singular 18-month extraordinary runway. And so it kind of, after we did this earthquake was kind of really when we realized what it was that we were doing and what it was that we were capable of on a broader scale. And this is where our single synthetic environments were born. And now we get to create these single synthetic environments for people around the world. So, and not only are we creating single synthetic environments around the world, so these are complex, multiple interconnected, live, geospatially accurate synthetic environments where we can create models from research, domain expertise, historical data, if there is any, oftentimes there isn't. We can model physical models, we can model physics-based models, we can model human behavior, sentiment, psychosocial, economics, and we continue to kind of add and grow. And this has created, over the past 7 years in doing this very carefully and very consciously, has led us to a place where we're now have an amazing team, and we've doubled during COVID too. We're debt financed if required, so we're bankable, as they say. And we've managed to, be able to toss pebbles, into different market sectors and really land at the top. So in 2021, we were at the top with the Electric Power and Research Institute after looking at, with the support of National Research Council, to develop the ability to synthesize grids. So now we synthesize grids, utility infrastructure, electric vehicle, electrification, mobility environments for the Toyota Mobility Foundation, and the list just keeps growing. So really, we violate kind of all the rules because we're not a product, we're not a service, we're a purvis, as I call it, and we have several different types of business models that we use and apply depending on the client, depending on the situation, but it's all really kind of still in the forming stages because we've had to invent it all, and now we're at the point where we're solidly in the world of better futures, and this is with our AI and ML background. So I'm gonna play a little movie just so I can catch my breath and show you kind of after seeing where we started awkwardly and then our first kind of transition stage, where we are now. And this is some of the media around what we're doing now with the Toyota Mobility Foundation as City Architecture of Tomorrow Challenge finalists in Kuala Lumpur, Malaysia.
Welcome to Synthetic Kuala Lumpur, a single synthetic environment or future lab of your city and citizens, produced by Run With It Synthetics. Synthetic KL encompasses all aspects of your mobility landscape today and in the future. A complete synthetic population that includes your citizens, their lives and livelihoods, their mobility choices, motivations, barriers, and opportunities, your public transportation infrastructure, along with economic impacts and sustainability outcomes. For the City Architecture of Tomorrow Challenge, Run With It chose a sample area to study that included 39,562 people in the Mid-Valley region. With the KL 2040 plan as a guideline, Run With It explored policy and infrastructure changes around train system security and accessibility and calculated the impacts. To arrive here, the foundation of our synthetic environments begin with people in your city. Run With It uses publicly available data sources from municipal studies, census, and research to synthesize an accurate population and households, including all of their relevant aspects of mobility patterns, access, and choice. This hyper-localized, reactive, responsive synthetic population then enables us to inflect traditional ridership programs such as fare increases and service enhancements, as well as even more subtle ranges of psychosocial behavior, such as reactions to roadway congestion, environmental motivations, even weather dependencies. In Synthetic KL, your new technologies, policies, and infrastructure can be trialed with this hyper-localized population to gain unprecedented, quantified, actionable insight into targeted effective mobility investments, aligning with KL's interconnected goals, truly a city for all. Thank you for the opportunity to present Run With It's Proof of Concept Synthetic Kuala Lumpur for your consideration.
So that's one of our happy endings that we have going on now during COVID even. And I just wanted to say that, you know, how much I think and respect, you know, of all of the work that's being done here in the ecosystem. And I think there is a really strong group that is, you know, really persevering and pushing through and making sure that we all are aware of each other and that that we can go forward and build this, you know, kind of better community together and ask questions and mentor and always be looking for help with somebody who's had a different experience. And I'm definitely available if anybody has questions. And just to really be able to say that I think it's super important to be able to realize that there are, you know, very different voices in this community. We're a women-led company. We're also a certified Aboriginal business, and all of our staff are GBA Plus certified. And we take that intersectionality that we have developed the capability for in our company, and we bring that to a world stage, and it's profoundly valued, and as well as, you know, how it's demonstrated in our approach to artificial intelligence and machine learning. And we're able to address these really kind of critical questions on a world stage and explore how diverse people experience policies and technologies and infrastructure and initiatives. So thank you.
Great. Thanks, Myrna. Are you open for some questions?
You betcha.
Okay, so there's
so I can see people.
a few people are typing some questions. So one quick one, and then I'll follow on some other ones. What's your technology built on? It's a question from Arthur.
Okay, so yeah, we get that a lot. So a lot of things. We have a lot of neural net IP, of course, from the 90s that we use to do kind of a lot of the filtering of data and even things as diverse as consumer surveys and stuff when we're building our synthetic population. And then we have a ton of AI built into our modeling. We have a whole bunch of AI in our optimization, but we in effect have our own platform.
Okay,
so
and then kind of just a related question is how long does it take to create a synthetic model? For example, if you created one, how long would it take to create synthetic Singapore?
That's a good question too, and we get asked that a lot. So a synthetic Silicon Valley was 3.5 weeks. We did a huge scenario for a dual disaster in the US recently. That project from start to finish, which included all of the analysis and everything, was 16 weeks. Synthetic Kuala Lumpur was 5. So it really depends on the complexity, the scale, the issues that they're looking at. But because we are getting really good at this, we kind of have know the key markers that we're looking for in a new environment. know the entities, and we have a massively talented research team that makes models from them.
Okay, cool. And then we've got a question from Katrina Regan Ingram, who's one of our regular attendees of the business meetup. She says, great story, not at all nerdy. So you've obviously, I don't know if you've changed it since Mac Mail said that. She wanted to know about, can you talk a bit more about your decisions to pivot and then ultimately to land where you are now? How did you decide when to shift gears and when to double down? And then I guess there's also a question from Evan Wayne saying, how did you avoid the future creep? Because I can imagine there's so many things you can do. So how did you make decisions on what to do and to focus on, and how did you make decisions of what not to do?
So what to do originally was what can bring some money in, because we decided we'd had a research company that was AI research, and you can just get lost in research forever. We didn't commercialize anything out of that. We weren't supposed to, but still, this time we decided we were going to eat our value. And nothing makes you more kind of tuned to what is actually, you know, approachable and acceptable by the market than eating your value. We still invent our way out of everything. We, you know, are avid kind of inventors. So we kind of look for that revenue stream to actually just fuel our addiction to invention. But it always now is really kind of additive. So we look for things, the question about pivoting, we really look for things that where there is disruption. So when we entered into energy, we had it figured out that we were getting called in whenever there was disruption. So technology or digital systems, when there was disruption in their scale, in their market, in their transition. Then it was disruption in smart cities market when there was just cities were drowning in vendors and they had to distinguish themselves. Then there's disruption in energy. Of course, everybody sees that coming. Electric vehicles are going to be the death of the grid. And so they're desperately trying to figure out ways of doing everything from investing in things to make us more resilient for black sky events, to where are people going to plug in their cars, how many people are going to buy EVs, is my transformer going to be on fire? So those are kind of really good places to be for us, is wherever there's a lot of pain. And so that's where we keep pivoting to.
So what about deciding what not to do?
What not to do? We're getting pretty good at saying that there has to be somebody there with budget and authority and money. And we don't always know who that person is going to be in a sector, but when there's enough pain, you know you're going to find the people eventually. And your product has to speak to them. So that's okay. Always a challenge.
Okay, we've got a couple more minutes for questions. If anyone wants to put them into the Q&A, there's one question here, and it kind of reminds me of a question I wanted to ask. Was that the environments you're creating are incredibly complex. You're creating, you know, models of entire cities or regions. And someone made the comment saying, you know, could you have used this by the city of Edmonton to build and model optimal LRT lines? So could you scale it down to create a simpler solution or a simpler use case?
Oh, absolutely. So we do some very discrete models. In March of last year, for example, we modeled masks on the streets of Edmonton, various masks being worn by people who were just going on a daily commute, and modeled aerosolized transmissions and the risk of contraction of COVID with varying types of masks in a really kind of discrete, this is their commute to work way. And so, you know, in effect, we can kind of turn our modeling to large scale things and to small scale things as well, a building even.
Okay. And then, so two last questions. One is where do you see yourselves in 5 years? Like in more on the kind of just the practical side of things, of like, if you can comment about how many people you think you'll have or markets you'll be in. What will Run With It look like in 2026?
That's a really good question that we're still kind of trying to keep our finger on the pulse of, because it changes almost monthly. But I think that we're going to have some amazing partners. So right now, we're in the world of strategic partners. With people like the Electric Power and Research Institute, we can supply, and we just did a big presentation today to the US Air Force. We can supply the synthetic models that are fueled by their research expertise. And so we're kind of creating the new applied research future. And it's research that's going to be evergreen. You know, it can continue to be contributed to over time. It can de-silo research and put it in context. So where that goes, and that's only one of our kind of initiatives or efforts in 5 years, I can't even imagine. But in the last week, it's taken us a long way. So I can see us growing really significantly.
Do you think you'll maintain like a primary base here in Edmonton, or will you see yourself have offices around the world?
We're already starting to have offices, I think the pull of offices in other places. But we have been able to do almost everything we needed to do here in Edmonton. I think the talent pool is there, and we have a lot of people who are interested in working with us. So as long as Edmonton maintains that it's a hospitable place to be, I think we'll be here.
Great,
yeah.
Good to hear. And one very last question. We have about 65 people on the call today. Do you have an ask of the audience? Is there anything that if the audience can do something for you, what would it be?
If the audience can do anything for me, that's a really good question. We will be hiring, I'm sure, throughout the year. We hire pretty much in spurts and madly and quickly. So if people are interested in what we do, they should drop me a note. An ask for me would be to really think farther in the future. I think that would help us all to think forward a little bit, and to not discount maybe others that have ideas and that may seem a little offbeat, or people may be struggling to communicate what they are because they haven't really kind of grown up yet, the ideas, or they haven't been flushed out yet, and to really support one another, I think, because it's a challenging world for innovators.
That's fantastic. Great. Well, if I could get everyone virtually to thank Myrna. That was a really interesting presentation, partially nerdy from my non-technical perspective, but really cool and really great to see. So thanks, Myrna, for that. Really appreciate that. So now we're going to switch gears, and we're going to shift over to Marcin. And I just want to bring up on the screen our next presentation. But before I switch it over to Marcin, I want to say to everyone in the audience that we're always looking for future presenters. So if you know of a company, large or small, that's got using AI and ML to create a competitive business advantage, or you know people that have got making interesting use of data from the data science side of things, please send us an email. There's the YAG-DS-meetup@altaml.com. That will get to us with your ideas. So we really appreciate that, because we want to populate the calendar moving forward. So Marcin, I'm going to turn this back over to you.
Perfect. Thank you, Bruce. And if you also would like to present, or know someone who would like to present more technical stuff, shoot us an email as well. Our next presentation comes from Navneet. He received his PhD in computing science from University of Alberta, where he was a member of Multimedia Research Center. And currently he's a lead ML developer at AltaML, where he leads all computer vision projects. He will be presenting on how to build trust in computer vision using explainability. Nav, floor is yours.
Thanks, Marcin. I'm just going to share my screen. Okay. Can you guys hear me? If somebody could just unmute and just let me know.
Yes, all good.
Okay. So my name is Navneet. I'm a lead machine learning developer at AltaML. My talk today is a bit on the technical side. I'm going to talk about this concept of explainability, and specifically explainability in the area of computer vision. So to kick things off, I'll start with computer vision. So computer vision, as you all know, it's a field of AI and ML that really tries to understand how the human brain interprets visual information, and then it tries to replicate the same thing in a computer. So anytime we have a decision that needs to be taken by looking at something, or like looking at a feed from a camera or something like that, we can use computer vision in those scenarios. And AltaML has had a lot of success in using computer vision as part of their engagements with clients, and we have helped them generate quite a lot of value in a wide range of areas. Those images that you see here are a few examples. We've dealt with a wide range of data, ranging from point clouds, from LiDAR cameras or like specific depth sensing cameras, to things like satellite images and video streams and things like that. In terms of use cases as well, we span a pretty wide range, from construction sites, industrial applications, to things like medical imaging and pet health analytics. Okay, so now as I told, we had quite a lot of success in really making use of computer vision, and the performance of all of those algorithms were really high. And then the main reason why the performance is high, the main core technology underneath all of this is still deep learning. So deep learning, as you all know, is this field of AI/ML, again, where we are using neural networks to kind of learn different patterns in the data, trying to figure out what's the areas of the data, or what patterns are there in the data that can be used to predict a particular outcome or come to a specific decision. Right. So as powerful as deep learning is, it comes with its own set of problems, and that main problem is what this code sort of represents by Ali Remy. He's a very famous researcher in the field. The main point of it is that deep learning is essentially a black box. You can try to figure out, you can get excellent results from it, but you wouldn't really know what happens inside. So I'm going to explain this in the context of computer vision. Just for the sake of this presentation, I'll be focusing on a really small area, which is image classification, because it's the easiest to explain. Right. So just to set context to the problem, here's what we'll deal with. We have an image coming in as input, and we have to decide what's in the picture. Like it's a classification problem. You have to say, well, this image has a motorcycle in it or motorbike in it, so I have to predict motorbike. And this is usually the structure of the neural network. Specifically, the area that I want to focus is that the way the information flows here. So it starts out with image pixels. These are just pixel values. Inputs go to the first layer of the neural network that processes that information, and then outputs some results, and that result goes to the second layer of the neural net, and then that output goes to the third layer, and so on, right? So information sort of flows through the network. Now, we can try to understand what's going on in this, right? So the way we do that is up to the data science. So the people among you who are familiar with data science, you know that regression weights can be visualized on just like a regular line plot. So similarly, we can try to do something like that with the specific kinds of neural nets that we're using. So because it's images, we are using what's called as convolutional neural networks. And in convolutional neural networks, you can try to visualize what kind of things are getting detected at each layer of that neural network, right? Remember, we have multiple layers. So we go ahead and do that, and this is sort of what we get. So in layer one, you can see that it looks like what it's detecting is regions of blue, right? So if you have a picture and there are blue regions in it, it's going to likely detect that particular region of the image. Similarly, there's a wide variety of patterns that it looks like it's detecting some sort of approximately diagonal lines, some sort of horizontal lines, and so on. And then you can see layer 2, those patterns become slightly more complex, right? And then as we go deeper and deeper, you can see that the kind of things that gets detected becomes more and more complex. So it goes from simple ideas like colors and lines, and then it goes to things like textures. But as you go further and further into the neural networks, you'll find that what kind of things it detects becomes really, really hard to interpret. Right? These towards the higher levels, it will become really, really arbitrary, and trying to make sense of it is not really possible. So ultimately, if you want to get back to the original image and try to figure out what led to this particular decision, it becomes close to impossible. So the crux of the story is that deeper layers are extremely hard to interpret. So what's wrong with this? Right? We go to our clients and we say that, well, we have this deep learning model and we have extremely high performance. So immediately the next question will be, like, why does it work? What makes the performance so high? Right? So that'll be the first question from the clients, and that will have ramifications, because if you just give people a magic box that just spits out predictions without knowing what's going on inside it, you don't necessarily inspire enough trust in that product. So that's the client perspective of it. And now if you flip to the other side, the ML dev perspective of it is, I mean, we are quite curious by design, and we want to know why things work. It looks like it's working, but why does it work? Is it doing something that you don't want it to do, or is the results that I get by accident? So that's sort of the ML dev's perspective of the same thing. Right? So we have this black box which we cannot interpret. So obviously that's the reason why we have this entire field of this ML space called explainability. So this is quite a well-researched field. There's been works starting from quite far back. And the list that you see here is sort of taken from a research paper. And I've listed the major papers that has come in this particular area. And obviously it's quite vast. It has quite a lot of acronyms in there. So what I've done is, again, I've narrowed down this thing to a single problem and sort of given a very, very high level overview of the main areas in explainability. Right? So specific thing we are dealing with, we are only concerned, at least for this presentation, the only thing we are concerned is, say we have an image classification problem. Is there any way we can figure out which parts of the original image is being looked at to come to a specific decision? Right? So that's our concern for this presentation. Now, if you go to the literature, we'll find that there's three major, like, broad areas in which this problem gets solved. So the first one is called as a perturbation-based method. Right? So what perturbation-based method does is that it'll take your model, whatever your trained machine learning model that does your image classification model, and then it's going to start toggling the pixel values of your image, and then it'll see how the output changes. Right? So it's basically different permutations of input pixels being turned on and off. And then it'll use a second sort of a surrogate model to kind of learn the relationship between what happens if I turn on this pixel and turn that off, and what happens at the output. So like basically, in a very crude sense, experimentation by perturbing the inputs, it'll try to give you an explanation as to what pixel change and what regions of an image leads to what decision. Right? So that's the perturbation-based method. Another range of methods will be covered under backpropagation-based methods. So backpropagation-based method is slightly different. So these techniques will require full access to the model for it to work. Right? So the exact way in which it works is it essentially starts from your output, your specific decision, this motorbike or whatever, and then it'll start going back, and then it'll sort of try to trace the activations back to your input, and then from that it can come to this decision that, okay, my specific activations of image pixels specific values of image pixels led to one particular decision. There will be complex math in this one, so you'll probably have to have some patience to kind of figure out what exactly they're doing, but this is roughly the way it works. A third category of things is called as activation-based methods. This is, I would say, a little bit more specific to images. So here what's happening is it does start from the output and start tracing things back, but it doesn't trace it back all the way to the images. It sort of gives you an explanation in terms of the features it detects. Right? So it'll look at certain layers of the convolutional network, and then it'll provide you an explanation of a specific decision in terms of those feature maps. So that's the activation-based methods. I have to sort of skim through all of this really, really quickly for the sake of time. But these are the broad areas, and then you can start exploring from here. Okay, now I'm sort of going to go to a different area, and I'll talk about a few of the experiences that we've had in AltaML, and then how we've used explainability techniques to kind of help solve some of our problems. So just to give a bit more context to that, we used explainability, but we used a specific method called gradcam++. The reason for that is just that it was the state of the art while we were exploring things at that point in time. And it had a bunch of benefits, like it didn't require us to alter our models really drastically, and then it was fast, and the code had licenses that we could use without any issues. Right. So we'll start with the first use case in the area of medical imaging. I'm not going to go too deep into what exactly it was doing, but suffice to say that it was a classification problem, right? What we had was we were given this sort of biopsy slides, and biopsy slide is one slide with slices of biopsy tissues kept on the slide. It looks like this, right? And what we had to do was we had to decide if some of those tissues, any tissue within this one is abnormal or not, right? If some of the tissues were abnormal, then you had to do something with it. And if it was not abnormal, we had to do something else. Right? From the ML point of view, it's just a straight up image classification. And the CV application of it, or the larger scale application of this was, it was involved in speeding up processing of these biopsies in hospitals. Right. So yeah, we have a problem defined: input slides, output come out with a decision of whether there was some abnormality in it or not. So obviously we started with a very, very simplest thing we can do, which is we've taken all of these set of slides with each of those labels, and if any of these slides, any of these tissue slices had any abnormality, we would be labeling this entire slide as abnormal, and then that would be given to us. We've put the entire thing to a deep learning based convolutional neural network based classifier, and we started checking performance. Performance was extremely bad. So then we went ahead and then tried to use our explainability to figure out what was going on. And then this was sort of the input that or the output from that we got, right? So this technique specifically was gradcam that we talked about here. What it was doing is that it was telling you wherever there is a red region, it basically tells you that those are the regions that the cognate is focusing on to take that specific decision. And you can see that when you look at this one, it immediately, it looks like it's focusing on regions that are really outside our area of interest. Like ideally it should be looking at these tissue slices and not the white regions of the slide, right? So that really quickly sort of led us to this conclusion that, well, the model is not looking at the right thing. So the takeaway from there was that, well, whatever, with the given data, your model doesn't focus on the right regions. So what we did was we helped it out a little bit by using a segmentation algorithm to sort of really isolate areas with relevant regions, and then started working with something like a per tissue slice label. And then that obviously gave a really good performance improvement. And with the data we had, we were able to make good decisions with it, and we got a good performance. So we took this model to the doctor, and this was sort of our output, right? We had a slice of a biopsy sample, a tissue. We had a black box ML model, and then we gave a decision. So people were happy to see the results, yes, but it was still a black box model, right? But the moment we sort of paired it up with an explainability model, that the degree of trust really improved, obviously, because you can say that, well, I'm taking a decision on this entire tissue, but then specifically the ML model is focusing on certain specific regions within that tissue, and that is what led to a decision of, like, things being kept as normal or abnormal, right? And indeed, when we showed this to the doctors, they actually confirmed that when they look at these slides, also they're also focusing on these regions. And this sort of, the fact that we really showed them which region of the image is being looked at to take that decision, that really helped the doctors inspire trust in our product. So that was a really big win for us. So now we'll go to another use case that we had, which is pet, in the area of pet health. So this is actually a product that we are probably going to release quite soon, and you can go to Happy or Not to figure out happyornot.app to actually try this out. The context of this is that, rather the business context of this is that most of the pet owners don't take their pets to the vet as often as they should be doing, right? Specifically the cat owners. So what would happen is that the health of your pet would have to be significantly deteriorated till you start seeing some sort of a bad sign, and then you will take it. So our value proposition is essentially that, we are going to give a computer vision based system that you can take picture of your cat and upload it to our system, and then we'll tell you if the cat emotion wise it's not happy or not, right? So if you find that the cat is not happy, then maybe it's time to take your animal to the vet. This was the entire idea behind this particular product. On the ML side of it, it's a straightforward image classification problem. Again, input images, output happy, not happy. This is a classification problem, and you can see that it sort of fits the kind of framework that we established earlier. And obviously we went through the whole process. We trained the classification model. We applied explainability on top of it. This is what we got. Like, input a picture of a cat. It will take a decision mostly by looking at the ears of the cat, right? So this was initially strange to us, but then with having more conversations with the doctors, again, we figured out that when veterinarians look at a particular cat and then decide if that cat is feeling uncomfortable or if there is something wrong with it, they look at what's called as a cat grimace scale. So you can Google this out, and this is an actual thing. So basically, when an animal is happy, then it'll have a specific template of the face. Like, ears will be really pointed up, whiskers will be like really extended out, and then it's going to look active and quite happy. As opposed to that, if the animal is not happy, there is some sort of a disease or there's some discomfort in the environment or anything like that, then it'll show distinct signs, and specifically it'll be things like position of the ear and whisker and things like that. And turns out our model had rediscovered that fact without explicitly saying that, well, you should be looking at these regions. Remember that the input to the model and what the entire AI system is getting trained on is just these images and the decisions. We don't explicitly tell it that you have to look at the ears. So that this sort of was a nice encouragement for us. Like, we knew that our system works, and then turns out the AI system is picking up a lot of interesting insights. So this really fueled my imagination, because there could be a lot of areas where we don't really know what is going on, but then through this sort of a combination of an AI-based explainability system, we could gain insights into entirely new phenomena that has never been discovered. So that was very, very interesting to me. Now, what the next stage of this, or that what happened next, was that again, as I said, this got us really excited and we started thinking about it. So one of the things that sort of came up in our discussions was that, well, it is looking at ears of the cat, but what if the cat does not have proper sized ears, right? So there are a lot of species of cats with oddly shaped ears, or like maybe there's not enough fur on the face, and there's like a wide variety of things that are possible there in terms of species of cats. So that sort of this chain of thought sort of triggered by this explainability sort of led us to this entire exploration of the idea of bias that could be there in our ML model, right? What if our model is not performing well on certain species of cats that are underrepresented in our database? So we went ahead and then we did a species-wise count of like what's our data set like, and what were the amount of data points per species, and then this is sort of the graph that we came up with, and that led to this a whole different study of performances per species, and then we started to address this problem of our model maybe not being fair to all subspecies, and then we're trying to solve that problem, and we are working towards it. So yeah, this was another nice use case of this, where it accidentally sort of led to this entire study of biases and fairness. And now, of course, we have this baked into all of our processes. Wherever there is any use case that involves a significant contribution to, we are making a decision that really affects something living or somebody's lives, then we start this entire study on explainability, on bias and fairness, and we ensure that the models that we models that we release are fair. Okay, so that was sort of the conclusion of my talk. So just final thoughts is that explainability techniques are indeed quite vital in computer vision, and then you should be using that. Even the most basic techniques are quite useful, and you can use it for a wide variety of things. And just as an interesting tidbit, we went to the Instagram feed of Grumpy Cat and then ran our system. Turns out Grumpy Cat is not grumpy. So like it gave us a prediction that it is happy, and then it's just highlighted the ears. And a little bit of the whiskers. It's not seen here, but in other images, it sort of highlighted the whiskers as well. So yeah, Grumpy Cat, not grumpy, confirmed. Thanks. So that's the end of my presentation. If you have any questions, I'd be happy to answer them.
All right. Thank you, Nav. That was very informative. Yes, we did get some questions. So people can still ask in Q&A section and vote on the questions. The first comes from Maria B. Thanks for talking about trust being built by AltaML with their clients for the black box approach. Is the trust only built after the results, or do you have a way of explaining why AI ML works?
So yeah, there is a way, and that's sort of how what we explained here. But I guess the broader context of it is you really have to tell clients how the system integrates in their environment and how certain decisions are made. Explainability is, of course, a critical part of it, right? Because that sort of opens up, and they can see how information flows and what is the reason for specific decisions being taken. So it plays out differently in different contexts. In case of NLP, it will be basically saying that, you know, the sentiment of this paragraph is so and so because these specific words are being looked at, or this specific combination of words is leading to that specific decision. In terms of a tabular data where you're looking at a different set of features, explainability result will look something like, it will give you a list of feature importances, and it will tell you a high value of that specific feature is going to push the model to decide towards a specific direction, right? These are for tabular data, it's called as a SHAP plot, and that's what is done. And there are, of course, other techniques, but SHAP is one of the more popular ones.
Okay, the next question. Are you concerned that the potential insistence on explainability will reduce the effectiveness of the results of the models? Can we understand the impact of a trade-off?
Interesting question. So most of our models for the time being, at least in the area of computer vision, we don't really make that big of a trade-off because the system really sits on top of it. So those the models that I was talking about, essentially, I mean, it doesn't alter the model itself. It is this something that sits above it, and then it analyzes the thing as a whole. So one possible area is that whatever techniques we have for explainability, it doesn't give you perfect information, right? You cannot have things like your logistic regression based things where it will give you the feature weights and you know exactly how it works. The SHAP and all, it will give you an approximate impression of how this works. So there is that fact. So if somebody insists that they want complete information, like perfect information of what's going on, then there are cases where we will be forced to use things like logistic regression, and then that will have a reduction in performance. So there's a slight trade-off there if you're extremely insistent on this. But for most practical use cases, we have not seen that. Our general method would be we would go to one of these popular techniques that gives us results, and then you can have these sort of surrogate models that sits on top of it and gives you the required explainability results.
I would argue that it could even improve the results, as you can see what the model is looking at. And we had one example where it wasn't looking at the things that are relevant. So it could overfit to some sort of noise or something that is not important.
Yeah, that's another, the debugging thing is an important one, I think. In vision, that was one specific example, but if you think about the same thing in case of tabular data and you look at explainability, you can find, if you find that it's looking at specific signals which you intuitively know is, either it's not available at prediction time and you somehow made a mistake and then that somehow leaked into your ML system, you can easily pick that up because you know that one feature is really having an impact on your decision.
Exactly. Okay, the next question comes from Sama Ahmed. How far away is this technology from being applied to humans with varying racial, cultural, psychosocial, etc. differences?
It's not far away. Like our company specifically, we pay a lot of attention to this. We have a committee that we have formed that focuses on AI bias and fairness analysis. So it has to really start from the business point of view itself. Like right when you start formulating this problem that you're trying to solve, at that point, from that point, you start thinking about this. Like if I take this specific decision, what's the impact it has? Is it going to marginalize a certain section of the population, and so on and so forth? So there's an entire business problem formulation context to this. And then once it does come to the ML side of it, we do another set of analysis, which can be, again, there's a wide variety of techniques that are out there, which can be used to specifically study if ML models are performing unfairly towards a specific subpopulation, right? You can take things like, okay, say you're doing credit card, chances of default of a credit card or something like that. You can check if there are specific regions that it is unfairly predicting, as always, it's going to default without careful consideration of the data. Right? So there are a wide range of metrics that you can compute, and then through that you can start coming to this particular decision.
I think kind of similar. Arthur Karloff, could it be possible that the explanations are contributing to the confirmation bias instead of true explainability?
Very possible, because the answer to that is that we cannot know more than what we know right now. All of the research, the things that I showed you, they have a specific way of testing things, right? They'll, if it's a classification problem, it's very simple to test. Like they'll show these pictures to human beings, and then they'll also ask them like, are those the regions that you look at while coming to this decision? And there is a set of metrics or quality of these algorithms that are judged on the basis of how similar it is to a human being. And there's another set of numerical metrics that you come to, and the way they do that is basically they'll remove the regions that the system predicts is important, and then they'll see the reduction in performance of the classification, right? So there's a mathematical way to kind of analyze if things are happening correctly in terms of prediction, and there's a human component to these experiments. So that these are the way these algorithms are evaluated. But if there is anything beyond that, there's no way we can measure it. So I don't have a definite answer to that question.
I think explainability could indicate that there is something wrong going on when, for example, it can show that, oh, it actually looks at on those biases, and that's how it makes decisions. So explainability is not biased by itself. It just shows how the model sees that, and the model could be biased, and explainability could indicate that there's something wrong going on with the data or with a learning algorithm. So the next question is from Hendrika. Thanks for presentation. Are there cases where the cat can be unhappy and not sick?
Yes, there are. If you put it under really enclosed conditions, basically if living conditions are bad, your happiness score will still be reduced. So you really have to take it to the vet to sort of figure it out. And we did indeed try to run a few experiments to figure out if we can automatically classify it as sick or not sick just by looking at the picture, but it didn't have any results. So our solution to that was, well, we know one thing for sure, that it is not happy. So why don't you take it to the vet and let the vet decide? But yeah, eventually we'll get there, I believe. Like once we've collected enough data for this, I think we'll be able to make a product that will tell you, well, cat is not happy. Why is it not happy? Is it because of sickness, or is it because of living conditions?
We actually working on that right now on the pain. So if is cat in pain, and if cat is in pain, then that's most likely something happening with the health. So there's a question that building off of that, how did you set the ground truth of happiness in your cat data set? You mentioned that's, was it labeled data from experts?
Essentially, yeah. I mean, without going into a lot of details, yeah, we had a lot of labeled data, and it was corroborated by experts. Yes.
We also we use variety of techniques, but we have this lack of collaborating with veterinarians.
Yeah. So our team, I mean, a couple of members of the team was actually veterinarians, and it's through them we learned a whole lot of things about this. So things like that cat grimace scale that I talked about, that the system seems to have accidentally discovered, that was actually confirmed by the veterinarians, and they're the ones who suggested a whole bunch of these additional changes in analysis and stuff like that. So yeah, we had experts in our group.
That kind of answered the question from Rayana, that asks, can you give an example from your experience that explainability ML adds a new perspective or information that has not been identified or known before? So here, I guess the veterinarians knew, but was more surprising for a team. Do we have any example where that would be?
I think maybe in some tabular data analysis, we would have figured out a whole bunch of things, because this is very common thing. Like we'll do the analysis, we'll take these results to the clients, and looking at these specific explainability results, then some of them it will be quite new to them, and they will get a feedback saying that, oh, we didn't know that was surprising. In the imaging space, we didn't notice anything completely new beyond this one, but yeah, there's always potential. Like nothing immediate coming to mind there.
And there's a question from Mohammed asking, are the models always 100% correct, or what's the error rate on those?
It was extremely high. I mean, and I'm assuming in the context of this, the project that we had, we were getting pretty good results, close to 80-85% or something in terms of our F scores. So yeah, it was actually performing quite well on the data set that we had. Mind you that we ran into that problem afterwards, in that for certain subspecies performances were slightly different, and then we observed cases where certain species would be predicted consistently as not happy, or certain species will be predicted as happy. So we would be detecting that earlier in that product, but it still be good.
Yeah, and I think the best story here is the developer who was developing that model owns a cat, and he actually was testing the model on the cat, and the model indicated all of a sudden that cat isn't happy, and he took it to the vet, and it turned out that the cat had ear mites, I think.
Yeah, ear mites. So
Yeah.
he was I think. Yeah, ear mites would distinctly predict. I think that's an example that really helps us out. But yeah, we've noticed a lot of other testimonies from other people as well, where they've said that, you know, your model really works. We did take it to the vets. I think our product manager Mish would have a lot of such examples.
Yeah, and another question is, how many images do we need for the model? I'm assuming everyone talks about the happy and unhappy cat, but in general, how many images for the models are needed?
I mean, if I answered that, I think Martin would be extremely happy, because that's the first question everybody asks, is that how many images do you need to solve this one particular problem? Answer is, I don't know. So general observations is that if a human being can be taught to sort of identify the differences between these specific classifications really quickly, given a binary classification problem, we find that it can be solved generally easily. I still cannot give you an exact count of number of points required, but if it is something that requires a lot of training for somebody to identify, you have to say, oh, look at that specific texture, and then, you know, there's a lot of intricacies to that, and obviously our model would not work. So just to give a little bit of context, happy versus not happy was a really simple problem to solve, because certain things were obvious, and you could actually be taught how to identify happy versus not happy, sitting with a vet for like around 10-15 minutes. But as opposed to that, if it was in pain or not, even the vets themselves had trouble trying to identify this just by looking at the pictures, right? So that's a really complex decision that I think involves either very subtle things or factors that are not really captured in the image. So yeah, no perfect answer there.
So it depends on the use case.
Yeah.
There's another question, if this can be extended to other pet animals, and I will try to answer that. Probably, but we need to have a ground truth, right? I know that we were first approached. People told us, like with the cats, it's kind of how they evaluate condition of animals, because other animals are a bit more explicit when they're in pain. Cats are extremely good at hiding that until it's too late. So a lot of that is based on that expression. But I think it is like every animal would have some characteristic that we just don't pay attention to because we're not used to that.
Yeah, I feel like this could be another area where we that point of explainability being used to discover additional facts could be interesting. So, you know, maybe I know for sure that there's an emotion classification for pigs, as far I remember reading about it. So maybe there's a distinct animal which we have not studied, but we, for some reason, through some signals, we know it's happy or not. And these techniques can be used to kind of figure out which parts of that anatomy is relevant to that specific emotional condition. So yeah, lots of interesting things.
Okay, perfect. Thank you, Nav. Thank you for the presentation. One question left, but it's more general about AltaML, how it compares to Expense in Ireland. I'm not too familiar with that company. What I could deduct from their website is that they offer some sort of AutoML services. We are a very custom service where we build the models for the company. We go in and investigate business problem, investigating how data sources and how to best apply the ML for this specific problem. So we're relying more on the machine learning developers to build solutions. So that's probably the difference here. Bruce, I see you on stage now.
I just wanted, before Martin, you sign off, I wanted to put up the screen once again just to announce our next event on March 3rd. So should we shift to that?
Sure, yeah. And then after that, we still have a networking session.
Yeah. Okay. So just so everyone knows, we're going to be holding our meetups on the first Wednesday of the month. And our next meetup on the business side is Nano Precise is going to be presenting and talking about their technology. And I also would encourage you to write down the email address on the screen, yag-ds-meetup@altaml.com, if you've got names for potential presenters, both on the business side and on the data science side. And as always, Martin, thanks very much for organizing the Remo side and taking care of the data science side of things. And I'll give you the last word.
Thank you, everyone, for coming. Thank you for the great question, great discussion here. And we'll be switching to networking session. As you can see, you're probably familiar with Remo platform, but you have the tables that you can join. To speak at the tables, you have to turn your camera and microphone on. And I just see that 2 more questions. Yes, so the next one is March 3rd, 6:30 Mountain Time. Okay, so thank you, everyone. And let's have some networking session.